Good morning, students. Now we are going to see characteristics of junction diode. First of all, we are going to see forward characteristics. So it is the study of the variation of current through the diode with respect to that applied voltage across the diode when it is in the forward bias. So it is the diagram. The PN junction is forward bias. Here you see that voltage oda positive terminal idoda connect பண்ணிருக்கோம். அதே மாதிரி negative terminal, the negative terminal will be connected into that cathode. So now the diode will be act as that forward bias. So here the external resistance R is used to limited the flow of current through the diode. The voltage across the diode is varied by varying that biasing voltage. It is the biasing voltage, that is the regulated power supply, DC power supply இங்க apply பண்ணிருக்கோம். The forward bias voltage and a corresponding forward bias current will be noted. So the graph will be plotted. So the graph எடுக்கிறோம். So x-axis பார்த்தீங்கன்னா forward voltage and the y-axis we are taken into that forward current. Okay, so this graph is called that forward VI characteristics of the PN junction diode. So in the graph we are getting some conclusions. First one, at room temperature, a potential difference is equal to that barrier potential. It required before a reasonable forward current start flowing across the diode. So this voltage is called that knee voltage or cut-in voltage or threshold voltage. It is approximately 0.3 volt for germanium and 0.7 volt for silicon. The current flow is negligible when the applied voltage is less than that threshold voltage. After the threshold voltage, we are increasing into the small amount of applied voltage means the forward current also increases. The second point, from the graph, the current flow is not linear and it is exponential. Hence, it does not obey that Ohm's law. The forward resistance RF of the diode is defined. RF that is nothing but forward resistance. It is always equal to the ratio of small change in voltage to small change in current. So in the forward bias, the diode will be act as that good conductor. So again and again, we are increasing into that voltage means a large amount of current will be flow through that diode. It may be destroy in the diode. Diode வந்து என்ன ஆயிரும், டேமேஜ் ஆயிரும். ஸோ ஒரு பர்டிகுலர் லிமிட் குள்ள மட்டும்தான் நம்ம என்ன பண்ண முடியும், கரண்ட்டை வந்து இந்த டயோடுக்குள்ள பாஸ் பண்ண முடியும். ஓகே, so the diode will be operate only within that threshold voltage and the breakdown voltage. Now we are going to see reverse characteristics. So in this circuit is used to study that reverse characteristics of the PN junction diode. So in the reverse bias, the P region of the diode is connected into that negative terminal of the regulating power supply and the N region is connected into that positive terminal of the regulating power supply. Here we are applied into that DC voltage. Okay, so the graph will be taken from that the reverse bias voltage and that current across the junction. So this graph is called that reverse characteristics of the PN junction diode. Okay, so in this reverse bias, a very small amount of current will be flow through that. There is a microampere current will be flow across the junction. This is due to that flow of minority charge carriers. That is called that leakage current or reverse saturation current. So this reverse saturation current is independent of that applied voltage. The reverse bias voltage can be increased only a particular value. Otherwise, the diode will be enter into that breakdown region. So it is another one graph for combined graph for forward characteristics and then reverse characteristics of the PN junction diode. Thank you. Good morning, students. Now we are going to see rectification. Rectification is the process of converting alternating current into direct current. So the rectifier also divided into two types. One is half wave rectifier and another one full wave rectifier. circuit. First we are going to see half wave rectifier circuit. So it is the circuit diagram for half wave rectifier. So in this circuit is consist of transformer, PN junction diode and the load resistor RL. Okay, so in the half wave rectifier circuit, it rectify only half of the AC input, either it is positive half cycle or negative half cycle. So only one half of the input wave reached the output. So this rectifier is called that half wave rectifier. During the positive half cycle, when the positive half cycle, the AC input signal, positive half of the AC input signal is passes through the diode. So now the A is act as that positive terminal. Here the B will be act as that negative terminal. Now the diode will be act as that forward bias. It conduct that current. That means it allow that current flow inside the circuit. Okay, so the current flow through that load resistor RL and the AC voltage developed across that RL produce that output voltage. That output voltage is V0. Here you see that waveform. So it is we are applying into that positive half cycle, then we are getting into that output. Input on the positive half cycle கொடுத்திருக்கோம், கிடைச்சிருக்க output பாத்தீங்கன்னா அந்த half of the அந்த AC input வந்து நமக்கு output கிடைச்சிருக்கு, V0ல கிடைச்சிருக்கு. Okay, so here AC will be converted into DC output நமக்கு கிடைக்கும். Okay, so and then next one we are going to see that during that negative half cycle, so when the negative half of the AC input is passes through that circuit, here the A terminal is act as that negative and the B terminal will be act as that positive. Now the diode will be act as that reverse bias. That means there is no current flow inside the circuit. The voltage drop across the RL also not occurring. Okay, so the voltage drop across the RL, it does not occurring that current. Okay, so there is no output. Here you see that we are given into that negative half of the AC signals, but the output, there is no output will be occurring. Okay, so the reverse saturation current in the diode is very small, so there is no voltage drop on that RL. Okay, so the negative half cycle, there is no output will be seen in that diagram. Okay, so the output of the half wave rectifier is not steady, the DC voltage, but it is a pulse waveform. This pulsating voltage is not sufficient for electronic equipment, so a constant or a steady voltage is required, which can be obtained with the help of filter circuit and the voltage regulator circuit. So of the half wave rectifier, so the efficiency is that the ratio of output DC power to that AC input power. Okay, so the value of half wave rectifier is, the efficiency range is 40.6%. Good morning students. Now we are going to see full wave rectifier. So in the AC input signals, both positive and negative half cycle passes through the full wave rectifier circuit. This rectifier is called that full wave rectifier. So it is the circuit diagram for the full wave rectifier. It consists of two PN junction diode, D1 and then D2, and then the center trapped transformer and a load resistance RL. The center is usually taken ground or zero voltage reference point. Due to the center tapped transformer, the output voltage rectified by each diode is only one half of the total secondary voltage. During the positive half cycle, when the positive half of the AC input signal is passes through the circuit, now the terminal M will be act as that positive potential, N is negative potential, and that G is zero potential. Here the diode D1 is forward bias, D2 is reverse bias. So the forward bias diode only conduct the current. The D2, it is in a reverse bias, there is no current flow inside the circuit. Due to the forward bias, the current flow only the particular direction, that is M, D1, A, G, C. Then the result, the positive half cycle of the voltage appears across that RL in the direction G to C. Now the output voltage is obtained. During the negative half cycle, When the negative half cycle of the AC input is passes through that circuit, the terminal N is act as that positive potential, M is act as that negative potential, G is zero potential. Now the D2 is act as that forward bias, D1 is act as that reverse bias. Only that current will be flow through that D2 diode. D2 diode வழியா மட்டும்தான் அப்ப current flow ஆகும். D1 will be act as that reverse bias. Now the current will be flow through that N D2 A G C. Now the current will be moving from N D2 and then A G C. இது வழியா மட்டும்தான் current flow ஆகும். As the result, the negative half cycle of the voltage appears across that R in the same direction. There is a G2C. Hence, both positive and negative half cycle of the AC input are rectified the output. Still, it is in a pulsating in nature. Okay, so and then the efficiency of the full wave rectifier is 81.2% because it rectified both positive half cycle and negative half cycle. So only its efficiency will be high. Thank you.